Yes, class. So see, in the last class, only electric flux was left, right? Rest of the portions we had completed. Now we'll just quickly revise certain questions from electric flux. This is a very simple, very easy question. So I'll directly discuss this. Rest of the questions first you will try by yourself, then we'll discuss it. All right. Now see, a sphere encloses an electric dipole with charge plus minus 3 into 10 to the power minus 6. You have to find out flux. So as rightly answered by Heather, Heather has answered no, yes. See, answer will directly be 0. What did we discuss in the last class? In case in electric flux, wherever you have to write down flux, that is charge enclosed divided by epsilon naught. And if it's a dipole, this is a dipole, no? For dipole, you have plus q minus q. That cancels each other, so that is 0. So flux will also be 0. It's like plus 3 into 10 to the power minus 6 minus 3 into 10 to the power minus 6. They'll cancel each other. That will be 0. So flux will directly be 0. Option B. Some more noted down, some more questions I'll write that you'll practice yourself, at least 1 or 2, then we'll move on to electric potential and capacitance.
Excuse me, ma'am.
Yes, say.
Ma'am, I couldn't solve a question in this chapter which stated that two identical charged space suspended from a common point by two massless strings are initially at a distance of d apart because of their mutual repulsion. This question uh, is like there is a slope kind of thing in this tan theta and all. I don't know how to solve this question. So should I send a picture of it to you?
Just a second, let me show you one question. If that is exactly same like that, then let me know. Otherwise, I'll text you my WhatsApp number. You can send me on that.
Okay, ma'am.
Is the question similar to this? Please check.
No, ma'am. No, ma'am. This is not the same question. It's a little different.
This is different. Either.
Yes, ma'am.
Okay, I'll text you my WhatsApp number. You send me the question. I'll send you the solution. All right.
Okay, ma'am.
After this question, we'll start with next lesson.
Ma'am,
Yes, Iram.
ma'am, the answer is option D, right?
Yes, right. I've seen your answer in the chat box. I was just waiting others to answer. Right. So
Okay.
let me discuss it then. C class. Option is D. Whenever you have no electric flux through cube, how to solve it? See, if charge Q is located within the cube, if any question comes no related to this part, it can give you any modification from this. So what you can do, see, it's like if you have a cube, within this cube, charge Q is held. So what will be the flux through the entire cube? Flux through entire cube. This is Q by epsilon naught. So entire cube means what? 6 faces. So flux through 6 faces is Q by 6 epsilon naught. Q by epsilon naught. Flux through 6 faces is exactly same as the flux through the entire cube. Flux through entire cube is Q by epsilon naught using Gauss law. So flux through 6 faces is also Q by epsilon naught. So what do we have to find? We have to find out flux through one face. That will be Q by 6 epsilon. This is our answer, but it isn't matching any of the options. So see, if you reduce it, pi gets cancelled. Q by, this is 24 epsilon naught. No. Q by, again, nothing is getting cancelled. 2 pi, this is Q by 12 epsilon naught. 4 pi gets cancelled. This is exactly Q by 6 epsilon. So option D is correct. Note it down. Any doubts you have, let me know. Then we'll discuss the next lesson. See, in this lesson, electric potential and capacitance, you just have to remember a few things. This is not a very lengthy lesson from your entrance perspective. Just break it into capacitance separately and electric potential separately. See class, capacitance will come separately. It has a different unit. Under electrostatics, till potential energy only, it's included. Now see, this formula is very important. V is equal to, that is the potential is equal to work done per unit charge. Fine. So how to define potential? It's the electrical property in scalar form, as in whatever you've studied in terms of electric field. That is exactly this, but in terms of vector form. So V is work done by Q. So it's a scalar quantity, so you can directly add it. And yes, class, now you remember you have to put the magnitude in voltage, that is potential. If something is coming minus, put minus. If something is positive, put it. And when you directly add it, algebraically add it, no need to use your vector laws. You can easily escape parallelogram law, all these laws. No need to use it. Directly just focus on this formula and no need to do the derivation part. Again, same thing. Minus for negative, plus for positive. KQ by R is your general formula. Superposition principle is also nothing here. You just have to algebraically add all the charges and nothing else is important here. From this, potential of dipole is very important. From here, you have to remember the general formula because questions are based on the general formula as well. And this formula is also helpful. That is without the dipole approximation. This is without approximation. So questions have come which involve your RNA. So you just have to check, suppose plus Q is there, minus Q is there. The separation between them is taken as 2A. This part is taken as A. Whereas this separation from the center to the point of calculation is taken as R. So if you see a very huge difference, that the dipole size is very small. If you see the size of dipole is small and this separation, this is increasing, then only jump to your ideal dipole approximation and use V is equal to Kp cos theta by R square. All right. Nextly, you have axial line and equatorial line, right? Now see, in axial line, you just put theta as 0 degree in your this formula. And see class, you have 0 for equatorial line because 90 degree cos 90 will become 0. So what is important? The main formula, generalized formula is important. But from your axial line and equatorial line, questions are asked. From this part, no questions are asked in the sense as in statement-based questions are asked. So statement-based questions are important from that element. All right. So like for equatorial, what is the potential in the sense questions will be based on that. This relation is the most important relation class. Whenever you're doing this lesson, make sure to begin with this. E is equal to minus dV over dr. That is potential gradient we call when something changes with respect to position. See, when something changes with respect to time, let's say distance is changing with respect to time, we call it as rate of change of distance is velocity. But when something gets divided by this position, by distance, we call it as gradient. The change in potential gradient, electric field is directly proportional to it. So this is important. You should remember this. Questions on partial derivative have also come from this. Significance of negative sign basically says that the direction of electric field is along where the potential decreases. This is exactly what it is. Otherwise, from this part is important class. Is equal to minus dV by dr from your NEET exam. From equipotential surfaces, you have very direct questions, very direct. Just remember your work done is 0. So if equipotential surface is given in your exam in some of your questions, take it as a hint to make work done as 0. All right. Now, from equipotential surface, electric field lines, you have statement-based questions. Now, electric potential energy. Electric potential energy, I'll just tell you to solve this in one form. Remember this formula class, that is sufficient. K Q1, Q2 by R12. Now suppose you have two charges, Q1, Q2, they are separated by R12 distance. So take this as K Q1, Q2 by R12, right? You will write it as this. Now see, suppose let's say a third charge Q3 is kept. So how will you write? You will calculate the number of interactions. So Q1, Q2, Q3, all are separated. So first interaction you will write about Q12, that is K Q1, Q2 by R12. Then you will write about Q2, Q3. So plus K Q2, Q3 by R23. Then 1, 3 plus K Q1, Q3 by R13. Like this, you will mention it. Understood? So however number of questions are given, you will keep on adding it. So for example, a fourth charge has been kept. Then in addition to these three energy, you will write the interactions of Q4 with Q1, Q2, Q3. Like this. All the number of interactions you will count and write. So if four charges are there, 6 interactions will be there. If 3 were there, 3 were there. If 2 were there, only 1 interaction would be there. Right? Like this, you have to mention this. And that's it. That is sufficient for your potential energy part. That will suffice all the portions that are needed for potential energy. Then capacitance. In capacitance, you have this basic formula everyone does well. Spherical capacitance, do remember 4 pi epsilon naught r. Do remember the value for Earth, 711 microfarad. If Earth acts as a conducting sphere, this value also you should know. From your parallel plate capacitor, no, you should remember these cases. That if both the plates of the capacitor, they are filled with air, completely separated by air. So formula becomes C is equal to epsilon naught A by D. If they are completely filled with dielectric constant. So K times epsilon naught A by D, dielectric gets multiplied. And if it is partially filled with the dielectric slab, then epsilon naught A, D minus T plus T by K. And instead of the dielectric, if conductor is there, see dielectrics are insulator. If conductor is there, so partially filled conductor. So for partially filled conductor, epsilon naught A by T minus T. So these four cases you have epsilon naught A by D, K epsilon naught A by D, epsilon naught A by D minus T plus T by K, epsilon naught A by D minus T. All these four cases you all should remember. Energy part is very easy. Half CV square, everybody remembers. Half QV, everyone remembers. Half Q square by 2C, everybody remembers this. But what you have to remember about these four parallel plate formulas for the completely filled, for completely filled dielectric, for partially filled dielectric, and for partly filled conductor, for partly filled conductor. All right. Then as I was mentioning, these three formulas everybody knows, and this is very basic. From out of all these three, one remember half CV square and just convert other if it is required. Half CV square is sufficient for you all. Half CV square, just remember. See, for 12th board exam, this wasn't important. But for your NEET examination, spherical capacitance you should remember. If spherical capacitors are there, so 4 by epsilon naught R1 R2 divided by R2 minus R1. This is also very much needed. So this you should remember this formula, that is sufficient. If any question has to come from this, it will be very direct from this formula. All the modifications will be made from parallel plate capacitor. Two things you should remember that are usually done in the form of question. If force is asked, use this minus Q square by 2A epsilon naught. And if energy density is asked, then use this half E square epsilon naught. These two formulas also you should remember. By chance question come. How this formula has come, the derivation part, that is no need. Because if a question come, it will be very direct, where value of charge will be given, or charge you have to find out somehow and just put it in the formula. So F is equal to minus Q square by 2 epsilon naught, you should remember, and energy density is very important. From theory part also, energy density is depending upon electric field or not, like this. So this is important. Sharing of capacitors is a separate topic. That out of the sharing of capacitors, loss of energy is not so very important, but common potential formula is important. C1V1 plus C2V2 by C1 plus C2. But I would suggest you, rather than remembering this formula, it's better if you learn it by charge before sharing is equal to charge after sharing. So whatever charge was there before sharing is equal to charge after sharing. In any ways, you will get the formula of common potential. But if you remember it this way, it would be helpful, because if any modification is there, so It's better if you are not learning the default formula. Loss of energies formula is there. It's not very important, but learn it. Of course, you have to learn everything. So C1, C2 into V1 minus V2 whole square divided by 2 C1 plus C2. That's it. You should remember this part only from this. That is sufficient from here. And one last thing, combination of series and parallel. Combination of series and parallel capacitors, everybody knows that is from, for if your capacitors, they are connected in series, so you reciprocally added it, and if they are connected in parallel, you directly algebraically added. Same is opposite is for your resistors, which are used in current electricity. For parallel, you reciprocally added, and for series, you added directly. So just remember one formula either for capacitors or for resistors, whichever you remember, just make the opposite for the other quantity. So I would suggest you to remember it for the resistors, and then just make it opposite for the capacitance. So now we'll start with the questions of electric potential and capacitance. I'll note down the question one by one. First, write down the question, attempt it, send me your answers, then I'll discuss it with you.
Ma'am, the ratio of, what is that written over there?
Ratio of surface charge densities of the
Ah,
sphere.
okay.
Okay. Heather, what I'll do is that I'll share you on I think you have sent me the photos also. So I have received your number. So on your number, I'll send you the link. I'll send you the links of these OneNote so that directly in your browser, Chrome or whichever you use, these notes will be open. All right.
Okay, ma'am. Thank you.
Yes, class. Last minute only Aram has answered, and your answer is correct, Aram. Last 1 minute, and I'll discuss it. Use the basic formulas. Charge, surface charge density. So, what is the definition of surface charge density? Charge per unit area. Use that and take out the ratio. Whenever no charge densities are mentioned, always try to write their definition. And potential is already mentioned, so concept of potential should also be used. Question is very easy. It just uses the division and ratios of surface charge density. Just put it and see one ratio should come out of all these. Yes, class. Yes, Heather and Iram are only right. Let me discuss it with you. See, class, formula whenever this is given, no sigma. Always write the definition. Sigma is Q by 4 pi r square for sphere. Why? Because area of sphere is 4 pi r square. And how do you write the density? Density, this is charge per unit area. That's how you write. So Q by 4 pi r square, this is sigma. Now see, for sigma 1 and sigma 2, just take their ratios. So Q1 for the first sphere, I'm writing it down. Q1 for the first sphere 4 pi R1 square into 4 pi R2 square by Q2. This is how the ratio will be. So if we cancel 4 pi, we'll be left with Q1 into R2 square by Q2 into R1 square, right? Now see, one more equation we can find out. See, when two charged spherical conductors, they are connected by wire. We have the concept of common potential. Common potential means what? Their potential becomes same. So if two conductors, they are connected with the help of wire, the charges will flow. Fine, charges flow will occur. But till the time both the spheres receive equal potential. As soon as charges flow only because of difference in the potential. Potential difference allows the charges to flow. So if the potential becomes same, charges aren't moving, right? So charges will move only till the time the potential is same. That is what is the concept even of common potential. That's why I was saying, do not remember its formula by heart so much. Remember that initial charge is equal to final charge, because it's the charges only that travel. No. So from common potential, you can say initial potential is equal to final potential. Now from the general formula, K Q1 by R1 is equal to K Q2 by R2. Now see, have a look from here. What is Q1 by Q2 from this equation? Isn't it R1 by R2? Now we can replace this Q1 by this Q2. So that so if you put it sigma 1 by sigma 2, R1 into R2 square by R2 instead of Q1 by Q2, R1 square. So at least these squares get cancelled. Finally, you have the answer sigma 1 by sigma 2 as R2 by R1, which is option B correct. Those who haven't written, write it down. I'll share some more questions. Everyone others also should at least attempt it. Send me whatever answer you're getting, even if it is not part of option. Whatever answer you are getting in your register, type me that. At least it would just give an idea that who all have at least tried the question.
What will be the syllabus in physics for tomorrow's mock test?
The same syllabus which we have covered, the same electrostatics only.
And
Not
vectors?
no, not vector. This just these two: electric charges and field, and electric potential and capacitance.
Okay.
Anna and Aram, just check your calculations once again. Same thing, Abhinav. Very slight errors of your 10. Just check. See all those who aren't able to answer. And Aram, the way you have mentioned also, you all are telling me dielectric constant K. You don't have to tell me dielectric constant, right? You have to tell me permittivity of the medium. There was a relation which I had told you in the last class. Yes, Aram, right. Now you're correct. Yes, Abhinav, answer is right. See, let me discuss it with all of you. Capacitance. See, the capacitance of a parallel plate capacitor with air as medium. So Abhinav and Iram, their answer is right. C class, C naught, that is in air, is given to you as 6 microfarad, right? So dielectric constant will be capacitance in the medium divided by the capacitance in air. What is the capacitance in the medium, in dielectric medium? In medium, it is 30 microfarad. Class, be very clear about this formula. Cm by C naught, epsilon by epsilon naught, F naught by Fm, because they only become confusing at then, and these are only the small formulas that are actually used instead of the rather long formulas which you have, especially in NEET exams. And I hope you must have seen the last 2 years papers, 2 to 3 years. Every question now you have to attempt. Initially it was like around 30 to 32 questions, or maximum 35 questions also. No, if those are attempted, the score gets increased. But now just solving 32 questions aren't enough. You have to solve all the 45 questions correctly, and the values are also not difficult. The calculation doesn't take time. It's just that you have to have a very good practice. So see, dielectric constant will be what? 30 by 60, that is K. This was all 5, that is answer which you all were giving. So this is K. What do you have to find out? Permittivity. K is epsilon, means in medium, divided by epsilon naught. So epsilon will be K times epsilon naught. So this is 5 multiplied by what you have, 8.85 into 10 to the power minus 12, right? Coulomb square per Newton meter square, right? When you solve, the value will be exactly this, option B, which is 0.44 into 10 to the power minus 10 Coulomb square per Newton meter square. Note it down. Let me share some more questions. Let me discuss it. Most of you are facing issues. I think Abhinav tried, but answer isn't right. There's an electric field in x direction if work done on moving charge of 0.2 coulomb through distance 2 meters along a line making an angle of 60 degree with x-axis is 4 joules. Then what is the value of electric field? Use basic formulas with you. Force is what? Force will be, first write work done. Work done will be in terms of F dot ds, F dot d. So that will be F d cos theta, right? Force into displacement into cos theta. And what is value of force from your electrostatics? F is equal to QE. Yesterday only I have told you this is a very basic formula. Very basic formula in the sense you will be using this a lot. So F is equal to QE. So work done will be QE d cos theta. Right. So electric field. Electric field is what? Work done by Q cos theta and D. Right. This is what electric field will be. Now let's see what all things do we have with us. Charge is 0.2 coulomb. Separation is 2 meters. Theta is 60 degrees. Work done is 4 joules. So once you will put it everything into this, now I think everyone will be able to solve this. E is work done is simply 4 joules. 2 into 0.2 into cos 60 directly you put it. So once you solve this, your answer will come out to be 20 Newton per coulomb. That is, I think, option D. So just check it, check which answer you're getting. This is the method how to solve it. Note it down. In whichever questions you get stuck, just see which quantity is missing and use all the formulas. Just think of all the formulas which you have used to get that quantity. No, see, answer to this is A. That is connecting two in series and one in parallel. Now, see, if we, okay, no issue. See, just no, put everything in these types of questions. These become lengthy. You have to check all the options. So if we, in this question, option is A, if we check it, two in series, one in parallel. For the A part, how much do we have to get? 6 microfarad. 4 microfarad. Yes, we have to get 6 microfarad. So see, two in series will be like this is one, and they are connected in parallel with this. So all are 4 microfarad. See, two in series, 4 and 4 in series. Whenever you have to solve capacitors in series, directly divided by 2 if they are identical. Or you can do it this way also, 4 into 4 divided by 4 plus 4. That will give you 2 microfarad. So it means their sum, this is 2 microfarad and this is already 4 microfarad. So see, now equivalent capacitance will be 2 microfarad plus 4 microfarad, 6 microfarad. So this was an easy question because your answer was in option A. Had it not been option A, we would have then tried B, then C, then D. This is how you try in such types of questions. Note this down. And all those who will write it, just text me done in the chat column. All right, those who have completed, you can leave. In the next class, we'll start with current electricity now. All right, thank you so much, class.